Hi my dear students, welcome back to Raghav Math e-learning. In today's video, I am going to explain how to find numerically greatest term and in competitive exams, what type of questions they are asking based on numerically greatest term. Look at these two examples. See here, I have taken one binomial expansion 1 plus x whole power 5 when x equal to 1 by 2. So power is 5. You know that we get 6 terms. Here I wrote all the 6 terms once you observe. So first term is 1, second term, third term, like that till 6th term I found that. Okay. And coming to this expansion also 1 plus x whole power 6 when x equal to 2. So totally you can get 7 terms in this and I have given all the 7 terms. And here from these two examples you can observe one thing. So here you see that the terms increases till one term and then it starts decreasing, is it? See here, first term 1, second term 2.5, so increasing, third term 2.5, fourth term 1.25, so start decreasing, next term 0.3, next term 0.03, is it? So the terms increases till one term and then it start decreases, is it? So here you see that coming to this expansion, first term is 1, second term is 12, third term is 60, fourth term is 160, fifth term is 240. See, till fifth term increases. After that decreases. Is it? Here we have 240, next 192, next 64. So I can write T1 less than T2, less than T3, less than T4, less than T5. But T5 is greater than T6 and T6 is greater than T7. So what is the greatest term? Yes, no doubt at all, the greatest term is fifth term. And in this you observe T1 less than T2, but T2 equal to T3, but T3 greater than T4, T4 greater than T5, T5 greater than T6. So here from this, what is numerically greatest term? See here, we have two terms as numerically greatest terms, right? So what are those terms? Second term and third term are numerically greatest terms in this expansion. So the conclusion from these two examples, in any binomial expansions, the terms increases till one term and after that the terms decreases. So you should remember that. Suppose I am taking the binomial expansion 1 plus x whole power n and I am taking that x greater than 0. My target is finding numerically greatest term. So we know that in any binomial expansion, the terms increases till one term and then decreases, is it? So here in this expansion also, the terms increases till one term and then decreases, is it? So here you see that, that is, suppose I am taking T1 is less than T2, is less than T3, less than so on, less than some TR, is less than TR plus 1. So here you see that T1 less than T2, less than so on, less than TR plus 1 means the terms increases till what term? R plus 1th term, is it? So here you see that T1 less than T2 means T1 by T2 is less than 1, is it? So from this you can write T2 by T1 greater than 1. And T2 less than T3 means T2 by T3 less than 1. That is T3 by T2 greater than 1, is it? So like that we can get TR less than TR plus 1. So I can write TR plus 1 greater than TR. Now you can take that TR plus 1 by TR is greater than 1. So here we have to find the maximum value of R where TR plus 1 by TR is greater than 1. Then you can identify that term, what is the greatest term we can give, is it? So I am going to simplify TR plus 1 by TR is greater than 1. So here you tell now tr plus 1. So what is tr plus 1? tr plus 1 by tr is greater than 1. What is tr plus 1? In the expansion, you know that ncr x power r by. What about tr? We write it as tr plus 1 form. So tr minus 1 plus 1, right? So what? It is nc r minus 1 x power r minus 1 is greater than 1. So here you see that ncr by ncr minus 1. So we have a formula for that, ncr by ncr minus 1. What is that? That is n minus r plus 1 by r. X power r by x power r minus 1. What is it? It is x greater than 1. So just you do the simplification. It will be n plus 1 into x minus rx greater than r. Is it? So what we get, you see, that is n plus 1 into x greater than r into 1 plus x. Is it? So from this you can take that n plus 1 into x by x plus 1 greater than r. Means what? R is less than n plus 1 into x by x plus 1. Okay. So here we got r less than n plus 1 into x by x plus 1. Is it? Here we have two cases. That is the case 1, n plus 1 into x by x plus 1 is equal to k is integer. So suppose I am taking this value is integer. What happens once you verify? So this become r less than k. Is it? So this become r less than k. And k is what? Integer. We know about r. R also integer. So r is integer less than one integer k. Means r values you can take 1, 2, 3, so on, k minus 1. Is it? So we solved this in equation, right? Suppose if you take that r is 1, what you get? So if you take r equal to 1 in this, you can get t2 by t1 greater than 1. Means t2 greater than t1. Means t1 less than t2. Is it? So if I put r equal to 1 in that, I can get what? t1 less than t2. If I take r equal to 2, what I can get? t2 less than t3, less than so on. At last you can take r equal to what? k minus 1. Then what you can get? That is tk minus 1 is less than tk. Is it? So we got one condition, that is t1 less than, t2 less than, so on less than tk. Is it? Next, see now. So in any binomial expansion, we know that the terms increases till one term and after that decreases. Is it? So to get for what value of r the terms increases, here we have taken greater than what? 1. Is it? So when the terms decreases, so the terms decreases. So terms decreases means now we take what? tr plus 1 by tr. Earlier we have taken greater than 1. Now we take what? Less than 1. Is it? So if you do the simplification again, then finally here by taking this, we end up with r less than n plus 1 into x by x plus 1. So for this what you get? R greater than n plus 1 into x by x plus 1. Is it? So already we have taken, it is what? Integer. So we got r greater than k. Is it? So r is integer and greater than k. So r is integer greater than k means what you can take? That is r equal to k plus 1, k plus 2 and so on till n. Is it? So just if you substitute these in this tr plus 1 by tr less than 1, then what we can get, you see, that is, suppose you take r is k plus 1. So here it become k plus 2. It become k plus 1 is less than 1. So you can get t k plus 2 is less than t k plus 1, right? So what? That means you write that in reverse order. You can get t k plus 1 greater than t k plus 2. Similarly, you can get greater than tk plus 3 and so on. Is it? So here you see that we take this is 2. So already we got t1 less than t2 less than so on less than tk. So the terms increases and tk plus 1 greater than tk plus 2 and so on till end. Is it? So here what is happening? So the terms decreases. Now we have to verify the relation between tk and tk plus 1. I mean, is tk less than tk plus 1 or is tk greater than tk plus 1 or is tk equal to tk plus 1. Okay. So now we are interested in knowing the relation between tk plus 1 and tk. Is it? So I have taken tk plus 1 by tk. So what is tk plus 1? It is nck and x power k by, what about tk? You can take it as k minus 1 plus 1, right? So what? nc k minus 1 x power k minus 1. Now here you see that this is like ncr by ncr minus 1. What is ncr by ncr minus 1? N minus r plus 1 by r. So what about this? It is n minus k plus 1 by k. X power k by x power k minus 1. It become what? It become x. Is it? So now I am going to simplify this. What happens? You see. So here already we have n plus 1 into x by x plus 1 is what? K. So from this you can take that n plus 1 into x equal to k into x plus 1, right? Now here you see that n plus 1 into x. So it is n plus 1 into x minus kx by k. Is it? So in place of n plus 1 into x, you can take k into x plus 1. So here you can take that k into x plus 1 by k. Is it? Now kx get cancelled and we left with k by k. What is it? 1. Is it right? So here we got that tk plus 1 by tk equal to 1 means tk plus 1 equal to tk. So I can write t1 less than t2 less than t3 less than so on less than tk is equal to tk plus 1 greater than tk plus 2 greater than tk plus 3 greater than so on t n plus 1. Is it? See here. So till this the terms decreases and then till this the terms increases and then decreases. Is it? So what about numerically greatest terms? tk and tk plus 1. So n plus 1 into x by x plus 1 equal to k and that k is integer. Then two numerically greatest terms will exist. Those are tk, tk plus 1. Coming to case 2. So earlier we have taken tr plus 1 by tr greater than 1 and we simplified that. And finally we left with r less than n plus 1 into x by x plus 1. Is it? So there I explained first case, that is by taking n plus 1 into x by x plus 1 an integer. Is it? Now I am taking that n plus 1 into x by x plus 1 value is not an integer. So not an integer means a real number, it's not an integer. So here we can express every real number as a sum of integral part plus fractional part. Is it? So here I wrote this as k plus f, where k is integer and f it is fractional part, that is in between 0 and 1. Is it? So what we got? We got r less than k plus f. So you know that r is integer. Is it? So here you can take the values r equal to 1, 2, 3 so on what? K. Is it? Can I take that k? Here r less than k plus f means it is like r less than 3.4. Then what r values you can take that? 1, 2, 3. Is it? So like that here r less than k plus f. So I can take r values as 1, 2, 3 so on k. Just you put all these values in this. Then what you can get, you see. that is T1 less than T2 less than T3 less than so on Tk less than Tk plus 1. Is it? Now we take that Tr plus 1 by Tr is less than 1. So here if you take less than 1, then in final answer you can get R greater than K plus F. Is it? So R greater than K plus F means you can take R values K plus 1, K plus 2 till N. Is it? Now if you put these values in this, then you can get T K plus 1 greater than T K plus 2 greater than T K plus 3 greater than so on greater than Tn. Is it? So if you club these two, then we can get T1 less than T2 less than T3 less than so on less than Tk plus 1 greater than Tk plus 2 greater than Tk plus 3 so on greater than Tn. Is it? Once you observe this, see till K plus 1th term it increases and then it decreases. Is it? So can you tell what is numerically greatest term? That is Tk plus 1. So here Tk plus 1 is numerically greatest term. So my dear students, you don't confuse. To find numerically greatest term, we don't do all this. Is it? So just we remember one formula, that is we find the value n plus 1 into x by x plus 1. So if it is integer, then two numerically greatest terms will exist. If that is not an integer, so if you can write that as K plus F, then only one numerically greatest term exists, that is Tk plus 1. And in some binomial expansions, sign alternatively changes. I mean positive, negative, like that. By that time, we take modulus and we give importance only for the numerical value and we give the answer. So in some binomial expansions, sign alternatively changes. So by that time, just you remember these points to identify what is numerically greatest term. So that is, if the expansion is like 1 plus x whole power n, just you find n plus 1 into mod x by mod x plus 1. If it is integer, then how many numerically greatest terms exist? Two numerically greatest terms exist. One is Tk, other is Tk plus 1 are numerically greatest terms. Suppose n plus 1 into mod x by mod x plus 1 is not an integer. Not an integer means suppose it is 2.5. So can I write it as 2 plus 0.5? So can I write that as integral part plus fractional part? Yes, it is not an integer means we can write that as some integral part plus fractional part. So I am treating like this, K plus F. So here where 0 less than F less than 1, it is the fractional part and it is the integral part. Is it? So this is integral part. Okay. So this time, what is numerically greatest term we learned? That is T K plus 1 is numerically greatest term. So by remembering this formula, easily we can answer the question related to numerically greatest term. Now we go through examples. See, in CET level exams, they are asking simply, in the given expansion, what terms are numerically greatest terms? So easily you can answer that. That is, here we have that n equal to 15, is it? But before that you do one thing. That is, you express this in the form of 1 plus x whole power n form. Okay. So to express into that form, here we want 1. So you take 3 common from this. What we get, you see, that is 3 power 15 into 1 plus minus 5x by 3 whole power 15. Is it? Now this is like 1 plus x whole power n. Is it? So what we have to find? So here we have to find that n plus 1 into mod x by mod x plus 1 value we have to find, right? So here in place of x we have minus 5x by 3, is it? Now we want that mod x value. So mod x equal to 5 by 3 into what is x given? 1 by 5. So 1 by 5. So what is this? It is 1 by 3. Just you put the value here and do the simplification. N plus 1 what? 16 into 1 by 3 by 1 by 3 plus 1. Is it right? So we got n plus 1 into mod x by mod x plus 1 become what? 4. Yes, is it integer? Yes, it is integer. So how many numerically greatest terms exist? 2 numerically greatest terms exist. Is it? So we got integer. So answer is T4 comma T5 are numerically greatest terms. Look at this example. Given fourth term in this expansion has maximum numerical value, then what is range of x? So this is also application of numerically greatest term. So in mains level of exams, they are asking this type of questions. So we know the concept. What is the concept we know? That is, in any binomial expansions, till one term, the terms increases and then decreases. So here what given? Given fourth term in this expansion has maximum value. So what? That means T1 is less than T2 is less than T3 is less than T4. So till fourth term it increases, then decreases, is it? So greater than T5 like that, is it? But here they mentioned what? Numerical. So you should take modulus for that, right? So that's why here we have T3 less than T4 greater than T5, is it? So from this I can write that T3 is less than T4. So T3 is less than T4 means here it is numerical. So we take what? Mod, right? So I can write that mod T4 greater than mod T3. So I can take it as mod T4 by T3 greater than 1, is it? So what is fourth term in this? You write that. So what is fourth term? That is 10C3 2 power 7 3 by 8x whole cube by T3. So third term I am going to take. What is this? 10C2 2 power 8 3 by 8x whole square is greater than what? Is greater than 1, is it? You observe this. It is like NCR by NCR minus 1. What is NCR by NCR minus 1? That is N minus R plus 1 by R, is it? So here you can take that. So it is 8 by 3, is it? So you simply remember like this. That is this top value and this bottom value. This top value minus this bottom value by R. That's all. So 10 minus 2, 8 by 3. That is only n minus r plus 1 by r. You don't confuse with that. And 2 power 7 by 2 power 8. So 7 2's cancelled. Here we left with 1 2. Is it? And here we have square. So it cancelled. And here we left with 3 by 8 x. Is it right? So into 3 by 8 into x into in denominator we have 1 by 2 with modulus is greater than 1. So here 8 by 3, 3 by 8 get cancelled and we left with what? Mod x is greater than 2. So we take this is in equation 1. So we have taken fourth term is greatest term. So fourth term is greater than third term. Fourth term is greatest term. So fourth term is greater than fifth term. Is it? So now I am going to take that mod T4 is greater than mod T5. Is it? So here you tell that. So from this you can write mod T5 is less than mod T4. So mod T5 by T4 is less than 1. Is it? So what is fifth term in this expansion? That is 10C4 2 power 6 3 by 8x whole power 4 by fourth term 10C3 2 power 7 3 by 8x whole cube is less than 1. Is it? So again you have to simplify this. See, it is like NCR by NCR minus 1. So what we do? This top value minus this bottom value, that is 10 minus 3, 7 by R value, that is 4, into, and here we have 2 power 6, 2 power 7. So 6 2's cancelled and we left with 1 by 2, into, here we have 3 by 8x whole cube, it will be cancelled and we left with 3 by 8 into x, is it? So it is 3 by 8 into x is less than 1. Is it? So just you do the simplification. So what we can get, you see, that is, so here numerator 21 and it is 64. So we got that mod x less than 64 by 21. So this is 2. Is it? So already what we got? Mod x greater than 2. Now what we got? Mod x less than 64 by 21. Means what? Mod x is in between 2 and 64 by 21. So 2 less than mod x less than 64 by 21. So you can give this answer. So range of mod x is this. Is it? And further also we can simplify this. So we got 2 less than mod x less than 64 by 21. We can simplify this. That is, if a less than mod x less than b, then the solution is x belongs to open interval minus b minus a union a to b. Is it? So here from this you can give x belongs to minus 64 by 21 comma 2 u minus 2 union 2 to 64 by 21. This is the answer to this problem. Already I explained how to deal with inequations in my first videos. Okay, if you haven't seen that, once you go through the playlist and once you watch the video how to simplify inequations, then you can understand how to get this. Look at this example. This is also one of the applications on numerically greatest term. Very important, once you observe this, if the middle term of 1 plus x whole power 2n is the greatest term, then what is range of x? Or sometimes they question you, greatest term in this expansion having greatest binomial coefficient. We know about greatest binomial coefficient. What are greatest binomial coefficients in one binomial expansions? You know that the binomial coefficient of middle term is greatest binomial coefficient, right? So instead of giving middle term is the greatest term, simply they are telling that greatest term having greatest binomial coefficient. So you don't confuse. So greatest binomial coefficient, where we get greatest binomial coefficient? In middle terms only we can get greatest binomial coefficient. So that means middle term is the greatest term, then range of x is what? Is it? So here you see that what is power? Even number. So here 2n is even. So you can tell what is the middle term, that is 2n by 2 plus 1th term. Is it? So what term it is? N plus 1th term, right? So n plus 1th term is numerically greatest term for this expansion. Is it? So n plus 1th term is numerically greatest, means we can take that n plus 1th term is greater than nth term and n plus 1th term is greater than n plus 2nd term. Is it? So earlier 4th term is numerically greatest. So what I have taken? 4th term is greater than 3rd term as well as 4th term is greater than 5th term. Like that. Here this is the numerically greatest term. So you can take that n plus 1th term is greater than nth term as well as n plus 1th term greater than n plus 2nd term. So do the simplification. So here you can write that Tn plus 1 by Tn is greater than 1. So what is Tn plus 1? That is n is 2n. So 2n Cn and x power n by nth term. How to write this? Tr plus 1. So Tn minus 1 plus 1, right? So what? 2nc n minus 1 x power n minus 1 is greater than 1. Okay? So just you do the simplification for this. Then what we get you see? That is, it is like ncr by ncr minus 1. So how to do simplify? This top value minus this bottom value, that is 2n minus of n minus 1 by this value. What? That is n. X power n by x power n minus 1. Is it x? Yes, it is x. Greater than what? Greater than 1. So what is this? 2n minus n plus 1 by what? N into x is greater than 1. So from this we got x greater than n by n plus 1. So we take this is in equation 1. So now we simplify Tn plus 1 greater than Tn plus 2. So from this I can write Tn plus 2 less than Tn plus 1. Is it? And also you can take that Tn plus 2 by Tn plus 1 less than 1. We do the simplification. So what we get you see? That is Tn plus 2. So Tn plus 2 means you can take that Tn plus 2 as T n plus 1 plus 1. Is it? That is like Tr plus 1, right? So it is like Tr plus 1. So what is that? That is n is 2n, 2nc n plus 1 x power n plus 1 by coming to this Tn plus 1, it is 2nc n x power n is less than 1. So we do the simplification for this. Again it is like ncr by ncr minus 1. So what is that value? So this top value minus bottom value. So what? 2n minus n by this value. What? That is n plus 1. X power n plus 1 by x power n. What is it? It is x is less than 1, right? So what we got you see? That is 2n minus n by n plus 1. So x less than n plus 1 by n. We take this is 2. So from first we got x greater than n by n plus 1. Now we got x less than n plus 1 by n. That means what? From 1 and 2 you can give the final answer, that is x is in between n by n plus 1 and n plus 1 by n. So what? The answer is n by n plus 1 less than x less than n plus 1 by n. Okay. Here I treated x as positive. That is the reason I didn't take modulus. You want, you can take modulus if they don't mention anything. My dear students, hope you enjoy the learning. Share this video with your friends and subscribe to my channel. Click the bell icon to get the latest notifications. Thank you.